Okay, so number 1, after you've added 5 and then divided by 3, you end up with this. How do you split that? You split it into two things. X plus 5 equals 4. Don't talk now, please. And x plus 5 equals negative 4. You got to split your absolute values and then solve, and you get two answers. All right, so that'll be easy. Let's do number 2. Number 2, I see a number line because it's got this in it. Anytime you have one of those in your problem, think number line. Because we solve these things by making a number line and then like saying it's like works in here and it works in there, but it doesn't work here and it doesn't work there. And then it's that kind of a problem. Okay? So the first thing you'd do there is subtract x from both sides. And then you'd have x to the third plus 2x squared plus x. And then you can less than or equals 0. Then you can factor out an x. And you'd have x squared plus 2x plus 1. And then you can factor it again. And then you'll find a bunch of things that are important spots. And you put them on the number line. Like 0 is an important spot, etc. And then you'll test your little zones by picking a number in the zone. Like, let's say I'm testing between 0 and 2, and I check 1, and it works. Then I go like this. So, anyway, that kind of problem. There's a whole lot of problems to know because the cumulative test that you're having on Monday is the one that just covers the last 3 days. So what's the test that you're having on Tuesday? That's the stuff that covers the entire semester. It's a jumble of everything so far. Okay? And it's good in that it's reminding you of this stuff so that when the final comes along, it'll all be fresh in your mind. Okay, but how are you supposed to remember stuff from the first week of school? Well, you are supposed to. You're not supposed to, like, just let it go out of your head. I know you're like, how am I supposed to keep it in there? By doing your review problems along the way and not going, oh, that's from a long time ago, I don't remember that, and skipping it. Okay? If you do that, yeah, you're going to end up having a hard time on this stuff. So anyway, back to how would you study for this thing? If I were you, I'd go to Schoology, and I would look at the files and links. Let me show you my Schoology page. It's right here. You can go to files and links. See? Files and links. And you go here to find video lessons for each day. And when you go there, I'll click on it now. Maybe I can make it work. There we go. It's my page that's got a whole bunch of videos on it. And how do I know which one I want? I just scroll through them. We are getting the right window here. I can scroll through them, and there are tons and tons and tons of videos. You're going to go watch every one? Of course not. But let's say that you remember that piecewise was your trouble. Well, there it is, Precalc piecewise functions video. Here's one on the doing functions in the right order. Here's another Precalc one on reviewing for the graphing test. Ooh, that'd be a good one. So you got tons of resources there you could use this weekend if you wanted to. I encourage you to consider using those. Again, it's on YouTube. It's through Schoology if you want to go that way. Probably the easiest way to find it. All right. Next thing. Let's look at another problem off your worksheet. Let's skip down to number 5. Remember, bigger on bottom, bigger on top, same on both. Remember that? That was for finding horizontal asymptotes. Okay? So what is that one, number 5? Is that bigger on bottom, bigger on top, or same on both? It's same on both because the degree is degree 2 on the top, and it's also degree 2 x squared plus 2x minus 8. It's also degree 2 on the bottom because I can see by that little 2 there. All right? So then, if they're the same on both, what's the deal for same on both? It's a ratio. What? Are you asking about recording? I believe I am recording, but I will double check. Yes, it's recording right now. Okay, so moving on. This is the same on both because the degree is the same on both. And if it's the same on both, it's a ratio of the lead coefficients, which is a 1 and a 1. So you go y equals 1 over 1. In case you wanted a quick review of that, same on both was y equals a ratio. The bob is bigger on the bottom, and there is a y equals 0 for that. And if it's a bot, remember the rule for bots? There's no bots, and there's none. There are no asymptotes for those. Okay, let's move on to number 6. Everybody look at number 6, please. I'm not expecting you to finish all these as fast as I'm going, but you just kind of stay with me and I'll give you tips. Number 6, that's about inverses. Okay, do you remember that if I have a function and then I make its inverse, that has a 3-step process to it? You change the f of x to a y and all that jazz. Okay, but if I want to know the domain and range of this, I just look at the function and figure out its domain and range. Okay, well, the function I have on number 6 is 2x plus 3. What's its domain? Will anything stop this or crash it? No, nothing crashes it, and therefore it's all reals. How about for the range? If you had trouble figuring out the range on this, what I would do, are you taking notes on this? Okay, all right, good. If you are doing the range on this thing, you would look like this. And I would then say, okay, range, what's range again? Oh yeah, it's how low it goes to how high it goes. And how low would this graph go? Negative infinity to positive infinity, all real. All right, so now how do I do the domain of my inverse then? Well, whatever the domain of the range, or sorry, whatever the domain is becomes the range, and whatever the range is becomes the domain. In this case, it's kind of dumb because they're both all reals, so it's super simple. But if this had been like all reals except x cannot be 0, then I'd make that become the domain down here of all reals except, well, that would have to be a y because it's a range sign. I have to change it to an x. All right, so just a quick reminder that the domains and ranges have to be flip-flopped. Moving on to number 10. Everybody look at number 10, please. Number 10 says, algebraically prove that f and g are inverses. It's okay, if they're inverses, that means that f of g of x will equal g of f of x will equal x. Do you remember that thing? F of g of x. Write this down. 3-column proof, just like that. Number 10. And then remember the key on these, you're not writing, use pencil, right. This is number 10. The key on these is that I need to prove that it equals x. I know it equals x. You can't just like slap it in there and say, oh, everything cancels and it equals x. I will not give credit for that. Let's do an example on this one, on number 10. We have to put g into f, so that's going to go into there. So it's 3 empty spot minus 2. And then I drop in the other function, x plus 2 over 3. Okay, here's my function. How do I prove that this turns into x? I can see that's going to cancel and that's going to cancel, but you can't do that. You have to show me what order they cancel in. So what has to be first? That has to be first, because it's a multiply compared to that, which is a subtract, right? So that's why this has to be first, and that's why the 3's will cancel first. And then I'll have x plus 2 minus 2. And then my plus 2 and minus 2 can cancel, and then I'll have x. All right, so you have to do that for all 3 sides. The third one is pretty much a no-brainer. Just bring the x down. If x equals x equals x, then we're good. All right, next thing let's talk about is 11. And this is the last one, so try to keep your focus for one more problem, and then we're going to switch to talking about the test that you guys had yesterday. But do you remember if you do f plus g of x, or f minus g, or f times g, that those all have really simple domains? You just take the 2 parent ones and overlap them. Remember that? You just take domain of f and the domain of g and overlap them on 2 number lines. All right? That works for all of those, but what's the one it won't work for? Divide f over g, and that's where you have 3 number lines. You have domain of f, domain of g, and the third one, which is the domain of g, can't be 0. So let's look at the g function in this case. The f function was square root of x, and the g function was x squared minus 4. Then it's saying that the g function, which is x squared minus 4, cannot be 0. So we have to figure out what would make it 0, because that would be our problem. And we would add 4 to both sides, and we'd have x squared equals 4. And then we take the square root, and it's so common for kids to just go x equals 2 and forget one of the answers. What's the other answer? negative 2, because it's absolute value of x. Remember when you take a square root of something squared, it's absolute value. Now it splits into x equals 2 and x equals negative 2. Those are the key points. Here's negative 2, here's 2. Where does it actually work? Well, works every place except those two spots. Empty spot, works in there, works out there, works right here. And then this is all, wait a minute, all reals for both of them? No, f of x, t of f is this one, and it has to be greater than or equal to 0. So here's 0, and it's like this. And you'd see where all of these overlap. And they would overlap between here to there, and they'd overlap here and there, and that's it. From 0 to 2, and from 2 to infinity. Okay, so there's one of your overlapping domain kind of questions, and that's, I figure, about all of the brain power that I can ask from you for right now. All of these have answers on the internet, on our Schoology page. The answers have been put up already. Okay, so you can check these over the weekend. So we've been testing a lot lately, I know, because I had to grade all of them too. Not exactly fun. And anyway, now I'm done for reviewing for the cumulative test for today, but I strongly recommend you especially look at more graphing stuff, because I really didn't talk much about graphing, but it was our easiest test. Most kids know how to flip the graphs and move the graphs and all that stuff. You'll probably be fine in that part of your review packet.